Okay, good evening. Tonight we're going to look at learning and classical conditioning. We have most likely either seen some of this in class already, or you're probably going to here pretty quickly. We have an interesting little chapter ahead of us here, because for a lot of people, they think to themselves, what does learning have to do with psychology? Why is learning even a thing? Because for us, we're studying the mind and behavior, and how does learning fit into that? Is this about school and school learning? Because that's kind of strange if it is, right? It is and it isn't. I would say that for sure, the learning that they're talking about is like how human beings can deal with their environment. We've talked about sensation and perception. We have discussed consciousness and what you're aware of and the levels of consciousness. And then there is learning, which is what shapes your behavior, or what gives you, I guess it just gives you your baseline of predictable behavior. And then you can also learn new behaviors or skills or knowledge in that case. So this is classical conditioning. You may have heard of Pavlov before, because it's kind of like a cultural reference that you've probably come across. It's sort of like if you've never seen Star Wars, but you've probably heard the line about Darth Vader and being Luke's father. So maybe Pavlov's dogs doesn't quite ring a bell, but it maybe is something you've heard of before. Let's look at this. What is learning? Most learning is associative. So that means that you make a realization that two things, events, or occurrences go together. When we talk about rigor, relevance, and relationship, and I know in our new school, the task seated 2.0, it's a little different than it used to be. But that was a big deal when I first started at AHS. It was all about rigor, relevance, and relationships. Well, the rigor is how difficult the class could be, so we've got that taken care of. The relationships are how well we get along as students, teachers, administrators, and working on those relationships. I think I do the best I can there. Associative learning is that relevance. So, for example, we had a parent conference today at my son's elementary school. Go Hidden Hollow, what are they? Roadrunners. And, he's struggling some with math because he's making some simple errors when he's doing his work. And his teacher said, one of the things that she does, she has a daughter who's in second grade. She says, try to make it as relevant as possible. And I thought, well, that sounds simple. But she ran through some scenarios where you would use math, like in the store, or you go into the gas station, or you're doing this or doing that. So it made me think a little bit. For students, a lot of times to have real learning occur where they can really remember it, it needs to be relative or relevant to them, where you can relate to that experience. So learning is putting two events or situations together and then understanding what that means. But learning itself refers to a more durable change in behavior or knowledge that's due to experience. So that you've gone through something and you've experienced it. That might be learning from reading your textbook or watching this video, or you put your hand on a hot stove and you've learned not to do that. There are three main types of things we'll look at. We're going to spend a lot of time with classical and operant conditioning. Observational learning, I don't hit as hard in this unit, although other teachers will, just because of the nature of the course, and we only have a semester this year to do this. We usually will highlight observational learning when we get to development and looking at how students or young people develop, and observational learning as part of that. And we covered a little bit in the first unit. Let's take a look at classical conditioning and where this comes from. Ivan Pavlov was a Russian scientist. He certainly wasn't a psychologist, not that they really had many of them in his day. But Ivan was very interested in science. He had already won a Nobel Prize, and he was suddenly, for some reason, really fascinated with saliva. And so he was using dogs to try to measure their levels of saliva. He would do that by attaching and surgically going into the salivary gland and capture some of their salivation. He was looking at that, but he stumbled upon what's called stimulus to stimulus, or classical conditioning learning. Ivan Pavlov was kind of like your typical nutty professor, someone who is really focused on his work, and Pavlov was single-minded in his approach. And when his lab assistant came late one day, Pavlov jumped his case and was like, "What are you doing? Why are you so late?" I'm sure he's like, "We got dogs to, milk the saliva out of," or whatever he's doing there. And the lab assistant said, well, sir, I don't know if you realize, but there are shots fired in the street, and, right in the middle of Russia, there's this massive revolution. And Pavlov kind of looked at him and said, "Next time there's a revolution, get up earlier." So that's the way he looked at the world, was not like maybe normal. But I think that's what it takes sometimes for scientists to make breakthroughs. They're single-minded and they're very focused. So much so, they may miss what's going on around them sometimes. So how is the fear of lightning a simple classical conditioning situation? Lightning and thunder is very interesting, isn't it? At any one time, all around the world, there are 2,000 thunderstorms happening. That's kind of crazy. Did a little research on lightning and thunder tonight and added this in there. It produces about 100 lightning strikes a second worldwide. That's 8 million lightning bolts every day, unleashing the power of 2 million tons of TNT. I never ever would have guessed or thought that there were that many lightning strikes. It's pretty amazing. So let's look at this here. We associate two stimuli together with lightning and then thunder. We see the lightning, see the flash, we hear the thunder. The speed of light is much faster than the speed of sound. So you'll see the light flash first, typically, and then you'll hear the sound. Lightning, then thunder. Lightning, then thunder. Lightning, then thunder. And what happens is eventually you will see lightning and then you'll flinch because it's lightning, thunder, lightning, thunder, lightning, thunder. And then you won't even need the thunder. You'll associate the fact that you fear the loud noise of thunder with the flashing light. And so all it would take is the flashing light to do it. So you've paired together lightning and thunder, and you've learned that when there is one lightning, there will be the other thunder. So another way of, thinking through this is just experiencing it. And so we'll do that right now. There's my thunder. I don't know. It's terrible thunder. That's not even good lightning, probably. But so do you get it? Do you understand it? I think this is one where people who have a fear of storms, if you've never really been in a terrible storm, maybe you've not developed the fear for it. But if this is something that's struck you a few times, or you've had home damage because of a storm, or you've been in the middle of a hurricane like we get down here in Houston sometimes, maybe you'll have more of a fear of it. This video is from the Annenberg series, Discovering Psychology, program number 8. It's on learning, but it's only the first 4 minutes of it, and what it does is we'll get into who Ivan Pavlov is and what he's all about. A very good video. They show some actual footage from his experiments. We should have watched this in class and probably will watch it in class, but let's look at before, during, and after conditioning. This is the full body of work here, and then what we're going to do is break this down into its individual parts and then build it back up again. So Pavlov used a tuning fork, and that's one of the reasons I like this display, because many times they show like a little bell or an actual ringing bell. The bell, Pavlov found out, was like too noisy and it startled the dogs. but a tuning fork, and the tone that it would create was just about the right pitch. So he would present food to the dog, and the dog would salivate. He was interested in spit, so, whatever. He would notice that sometimes he'd bring the food to the dogs to kind of collect the saliva, and the dogs started to salivate before they even had the food. And he thought, this is weird. Shouldn't you salivate after the food's in your mouth to break it down scientifically? Well, it turned out that he realized they were making an association. Sorry about that. I'm not feeling very well, and yawning is actually a symptom of MS, which is just messed up. But I yawn a lot and sigh a lot. It's just because I'm a little tired tonight, so sorry about that. Where were we? So he notices that there's this association happening. So he decides to pair the tone with the food, and that's what you're seeing here during conditioning. It's the low left corner. During conditioning, you have the neutral stimulus, which is the tone, and the unconditioned stimulus, the food, and that, when paired enough together over and over and over again, and it needs to happen within just a few seconds, presenting itself. You can't have too much of a gap. You'll then, after this conditioning happens, you'll have this situation occur at the bottom right, where the CR becomes the CS, where your tone turns things into a salivation happening. The conditioned response of salivating is therefore becoming a conditioned stimulus. So let's walk through this again. The UCS is the food, the unconditioned stimulus, and the UCR is the salivation. I want to say salvation. That might seem like salvation to the dog. Hallelujah, there's food. But salivation. So food is the unconditioned stimulus, because it's the stimulus that doesn't need conditioning to provoke a response. That response is the unconditioned response, the salivation. You have a tone situation here, which is a stimulus that absolutely does nothing. A dog doesn't care and doesn't salivate about the tone. There's nothing to make him salivate. There's nothing to make him do anything. He just hears a tone. But during conditioning, when you pair the neutral stimulus, the tone, with the UCS, so we're pairing the top two and getting the bottom part there on the left, you end up with an unconditioned response. It's unconditioned because you can't test that response until you take away the food, the unconditioned stimulus. You take away the unconditioned stimulus, and now if you notice that the CS, the tone, rings and creates salivation, you now have a conditioned response. So let's walk through another step of this and look at it again. Unconditioned stimulus is a stimulus that naturally, automatically triggers a response. The unconditioned response is the unlearned, naturally occurring response to the UCS, which is salivation in this case. UCS and UCR, it's both happening on the left side. The CS, which is the tone, and this is both happening on the right side, is an originally irrelevant stimulus, the tone, that after association with the UCS becomes a triggered response. The CR is the learned response. So the trigger, the CS, the tone, evokes on its own the CR, the conditioned response, which in this case, the tone, leads to salivation. Hopefully you understand this. The first time I ever showed this to students, I broke it down like these 2 slides alone. That's all I did. And was like, okay, we got it. And I figured they'd understand it. I've shown you this. I showed this to you with the entire thing first, seeing the whole process. Then we broke it down into its individual pieces. Okay. And now let's see it all again. So hopefully this will make some sense and ring a bell when the test comes. No, that's too easy. I wanted to show you a couple of these. Obviously, we're not going to show you these videos because we don't have enough time, and it won't play well within my video. But you can go to the notes and play this. This is the one from AHS students from a few years ago, Shelby and Kyle and Danny, and they take the dog through some classical conditioning. We can also talk about whether or not this is actually a very legitimate and ethical procedure that they do. They claim that it is ethical and moral because they take the dog through the process where it unlearns the fear that they create in it. But it's a pretty sticky situation. You don't want to put animals or humans through any pain or harm if you can help it. And they stated in this case that they felt like that was the best way to do it. So you can make your own judgments for it. That's one of the reasons why I kind of enjoy the experiment, because it leads to that good discussion. Anyway, it's a pretty good one. The classical conditioning example. Oh, and I also want to mention to you, watch for what happens with Shelby in this, and how she calls for the dog during the ringing of the bell. And there's a little tone that they sound on it, like a xylophone thing. When she's calling for the dog to come, that becomes another stimulus that the dog will generalize into, meaning that not only does the bell evoke fear in the dog, but so does Shelby. That's her dog. So she gets really disappointed when she sees that happen. That's a generalization. We'll get more on that later. This is the clip from YouTube called Classical Conditioning Through the Office, which uses an Altoid mint every time the gentleman's machine in the tie there, in the white or blue shirt, every time he restarts his computer, and it was a Windows machine, so they had to do that a lot. Every time he has to do that, he gets that restart tone, and he decided to participate in a little classical conditioning experiment by offering Dwight, who sits across from him, an Altoid every time the tone would sound, to the point where all he has to do is restart, and Dwight is expecting to get an Altoid. So let's walk you through what that would look like here. Jim asks, do you want an Altoid? And that's the UCS, because it's an unconditioned stimulus. And Dwight reaches out his hand. It's an unconditioned response. The computer tone is a neutral stimulus. It's not on its own going to evoke any kind of emotional response. The computer tone ends up being the CS, the conditioned stimulus, and we'll know it is if Dwight does reach out his hand when he hears the computer tone alone without the Altoids being offered to him. And he does, of course. Here's another really good example with the show Frasier. He is a radio call-in show person, or a guy who has his own radio call-in show, who is a former psychiatrist, practicing psychiatrist, and Frasier's the man in the foreground here. He's originally from Boston, moves to Seattle, and has this show. And his producer, Roz, I think her name is, Roz, she's sitting across from him, and he shows the red balloon scenario to kind of get back at his friend who played a prank on him, or a guy who played a prank on him at the station. So here's what I want you to do is check that out and then come back and we'll look at that as well. Okay, so the Seahawks losing. God, the freaking dog. Come here, boy. Come here, boy. Griffey, you were just sleeping, buddy. Oh, brother. Hey. Oh, boy. You never bark except for when you're asleep. Scared the life out of me. So maybe he's that's not a neutral stimulus. I just have fear all of a sudden. More on that later. I think he heard the washer banging around. We're washing clothes, and he jumped up because of that. Goodness gracious. So let's walk through this. See if you can fill out the rest. This isn't that hard. It's kind of similar to the last one. What is the Seahawks losing? The UCS, unconditioned stimulus, because on its own, it's a stimulus, but it provokes what? An unconditioned response. That stimulus makes the guy in the Seahawks hat there very sad, Makes sense. That's just what happens. Texans lose, and there you go. Texans lose. I am sad too. So there we have it. Let's not have the Texans lose. Frazier decides to attach a red balloon to his car every time the Seahawks lose. That is a neutral stimulus on its own, but he's going to condition it because each time the Seahawks lose, there's a sense of loss in Bulldog, I think his name is. And then Bulldog is going to see the red balloon every time. When he sees the red balloon on his own, that's going to create a conditioned response with a deep sense of loss. So hopefully you understand that one. Let's go back to the original example here with my former students. What was the UCS, UCR, NS, CS, and CR in their experiment? Jumping and scaring the dog was the UCS, the unconditioned stimulus, because on its own, it's going to evoke a response. It's going to create fear in the dog. So it's a stimulus, it creates fear. But the bell sound alone that Danny would ring doesn't create anything other than just a sound. He's not going to be fearful because of the bell sound. But the bell sound could become the conditioned stimulus when it is paired with the dog being fearful. Okay, this makes sense to you? By the way, Danny and Shelby are at the University of Texas, or that's where they are attending. And I believe that Kyle, whose back is to you as he's scaring the dog there, he is at Baylor University. So we did this in class. We paired up and came up with an example. Think back through your example. If you're watching this before class, think up an example. So when we get to class, it'll be easier to do. Notice again that the unconditioned response always becomes the conditioned response. The neutral stimulus always becomes the conditioned stimulus. But we only know that when you take away the condition. So let's go back to this example. When you take away the jumping and the scaring of the dog, that's when you get a chance to test to see if the neutral stimulus can become the conditioned stimulus. Another way you can double check your response to this is to fill this in. And I always tell students too, your hypothesis is really important. So kind of step through your hypothesis. What do you think will happen if you pair unconditioned stimulus with a, you get a typical response. Now you're going to pair a neutral stimulus with that response. And what are you going to try to condition? So this might help you do that. We'll look at this in class as well. So another one of these fantastic videos by Chuck Shawhorn. I want to, it says Chug. I don't know what that says. It should be a K at the end, but of his name, Chuck. But Chuck Shawhorn, he has a good one here, and he walks you through a bunch of other examples that are really good. Let's talk about Pavlov. He spent the rest of his life outlining his ideas, and he really discovers 5 critical terms that make up classical conditioning. The first being acquisition. And acquisition is basically that neutral stimulus becoming conditioned. Extinction is when you walk the dog through, no longer having that stimulus be conditioned. The tone, in his case, that sound from the tuning fork, if that tone no longer provokes the dog to and evokes a salivation from the dog, it is extinct. But that extinction can sometimes be overcome and spontaneous recovery occurs. And also, a generalization may occur. It may be if the same person is doing the experiment all the time, that person ringing the bell might be the person who the dog will start to salivate when he sees, if he only sees him when there is food being brought there. Or like in Shelby's example, she's calling the dog while they're scaring it. The dog associates not only the bell, but generalizes also Shelby calling the dog for it. Discrimination is when the dog might be smart enough to realize that the bell is what might be doing it and not Shelby, he can discriminate against the two and say Shelby's cool, that Belle is bad. Let's look at some more examples. This will help you here. Here's the drops of saliva elicited by the CS, the conditioned stimulus, from 0 to 15. Here's the 24-hour rest period and another 24-hour rest period. So they're taking you through 24 hours, one day. You have the acquisition that seems to go pretty well, and they're getting 10 to 15 drops. Then they no longer are doing trials, and it dips down a little, and then it dips down a lot, and a lot, and a lot. But there's a little bit of time where it zigzags back up and forth. The next day, it's interesting, there's a spontaneous recovery, but then it goes quickly downhill again, kind of back to where it started at the end of the first day. The second has more of a spontaneous recovery, but then with just the CS alone, it does not pick up steam again because you're no longer pairing them together. So acquisition's the initial stage of learning, like we've been looking at. The neutral stimulus is associated with the UCS, and therefore neutral becomes conditioned, and it becomes the CS. Does timing matter? The CS, the conditioned stimulus, should come before the UCS, and they should be very close together in timing. Let's look at extinction. You've got that drop-off, that major drop-off. The diminishing of a conditioned response will eventually happen when the UCS does not follow the CS. That makes sense, right? The unconditioned stimulus is no longer following the conditioned stimulus. Spontaneous recovery. When you got the CS alone, but all of a sudden you see a sharp uptick. Like right here would be spontaneous recovery, and I would even venture to say that here is spontaneous recovery, the second day or after a 24-hour rest. So reappearance after a rest period of an extinguished conditioned response. The conditioned response returns. And if you don't really know what spontaneous means, that means like you would jump in the car and take off and go for the weekend and not really have any plans. You're not even sure where you're going. You're just driving. That's spontaneous. And this doesn't seem to have a rhyme or reason. It just seems to pop back up. All of a sudden the conditioned response occurs even though it's not being paired. So, generalization. The tendency, once a response has been conditioned for a stimulus similar to the conditioned stimulus, to elicit a similar response. So let's walk you through the scenario at the top there. You got the meat paired with a circle. The dog is going to salivate. This is a conditioned situation. The next part, the stimulus generalization, where you'd see the dog would see a circle and salivate. But if he could see the site of an ellipse, which is not quite a circle, it's taller, and still salivate, that means that for these dogs, the CR of salivation, to the site of the circle showed stimulus generalization to that of the ellipse. So there you see it at the bottom. And you can tell in the bottom right, he is salivating. The classical conditioning theory of phobic disorders, which we'll talk about down the road, states that the learned fear to a CS generalizes or transfers to other stimuli, with the greatest amount of transfer occurring to stimuli that were the most similar to the CS. So in our early example with thunder and lightning, maybe you are afraid of lightning, okay, but a kind of a similar response that you could generalize and have the same learning occur with it if maybe the lights flickered and they flickered really fast and it gave you this sense of lightning. You would have this really deep, fearful, phobic feeling, and that might just bring that on. Panic attacks sometimes function in this way, where something just reminds you, and you can generalize that learning that you've done previously to create fear or anxiety, and now it's occurred again, but it's done so in a way that you wouldn't think would on its own do that. Dogs have an awful lot of problem with generalization and storms, and they'll go hiding right away because they'll see lights flash or something else, or just protecting themselves. So discrimination would mean this. that the circle paired with the meat elicits salivation, but when the ellipse is paired with nothing, and you can't pair it with the meat, or else you're creating a connection there. When the ellipse is paired with nothing, you get no salivation. That's the difference here between this one and the one before. You see, the ellipse is getting salivation. There is no salivation happening for the ellipse here. That's the ability to distinguish between the CS and other stimuli that does not signal the UCS. So as described in the last slide, dogs showed stimulus generalization to the site of an ellipse when they had been classically conditioned to salivate to the site of a circle. If one conditioned to pair the circle with the meat, but never paired the ellipse with the meat, over time the dogs stopped salivating to the ellipse, but continued to salivate to the circle. That is, the dogs were able to discriminate between the ellipse and the circle, and they learned that they received meat only after seeing the circle. This is called discrimination. Classical conditioning theory of phobic disorders will look at this as well. Individuals learn to discriminate between the CS that is followed reliably by fear-inducing UCS and stimuli that, though similar, rarely or never followed the UCS. So, for example, the dog that's fearful of all men because he's been treated cruelly by a particular man, it will probably learn to be fearful only to the man who abused it if most other men the dog meets treats them kindly. And this is also sometimes referred to as systematic desensitization in a way, where you're maybe slowly over time losing your ability to associate these two stimuli together. Here's a good graphic to let you think about it. What if the man had a beard, and I happen to just be growing one of these, and a dog just about snipped at me yesterday, so maybe that was what was going on here. Maybe a person that the dog remembers, and that's the cloud above him, was very mean and abused the dog. So now this man here with a tie on is offering a treat to the dog. The dog doesn't want any part of it, and he's scared. He's generalizing that man with the beard with the other man with the beard who may have hurt him. So how would you define stimulus generalization in your own words? And how would you define stimulus discrimination in your own words? Can you think of some examples? The UCS of a loud noise evokes fear. The CS, which is the rat, can evoke fear then as well if they're both paired together. The CS-related stimuli or other furry objects like a slipper, a white slipper, and a white rat, they may look similar. They may also then induce fear. Would that be generalization, or would that be discrimination? Definitely generalization. Here's one last one here. A song, which is a neutral stimulus, it's just a song. But you have an unconditioned stimulus that occurs during the song. You are kissed. I'm not kissing you there, I'm just kissing just to make you think of it. That provokes an unconditioned response. Your heart is racing because this is maybe exciting, or maybe you're scared. I don't know. The conditioned stimulus of the song will then provoke your heart to race, or you will prefer that song because you have associated that song, the stimulus, with another person and time with them that was important to you. Or vice versa, a song was playing while someone attacked you and jumped you and started beating you up, and you're like, man, every time I hear that song I get nervous and upset. Well, no wonder. You have paired together those two stimuli. Let's look at crazy John B. Watson in classical conditioning. He's the founder of behaviorism and the little Albert experiment. And I say crazy because this is really pretty bizarre. He took Pavlov's ideas and put them to new and more rigorous tests, little Albert and generalization. Watson demonstrated that he could create and provoke fear in a child in response to a neutral stimulus, which is a rat. When the rat was first showed to the baby and shown to the baby, baby looks at it, kind of pets it. It is not any big deal. The rat doesn't really make the baby fearful in any way. But when Watson stood behind the baby and hit like a gong or this big lead pipe and made a really loud sound, and the baby started pairing the loud sound with the rat, now he generalizes a fear of the rat because he just seemed to be crying whenever the rat was there because of the noise. This is something we do every day, and we may not realize it in good and bad ways. But there were some real serious problems with little Albert's experiment here that Watson and Rayner did, and we're going to discuss those in a minute. But first, let's think if we can go through this here. The UCS was the loud noise, unconditioned stimulus. Think of stimulus as something that could evoke a response. So really, if you're trying to do this and the question asks you for the UCS, think of something that's going to provoke a response. There I go again. I must be boring myself. I'm just really tired. UCR is fear, crying, madness, and misery from the baby. The loud noise creates that. Now there's a neutral stimulus, the rat, who on its own didn't do anything to scare the baby, but when it was conditioned, it became the CS, and it provoked fear, which was the UCR. So if you're looking at this, the UCR always becomes a CR. This NS always becomes a CS. So if you're ever asked to kind of play out the scenario, you should be able to do that pretty well. And I will add that if it doesn't produce fear, well then it's not a CR. It just doesn't work. It's not a conditional response then. The shirt at the bottom is kind of funny. It's a good time to look at it now because we're going to kind of rip up Watson here in a minute. But it says this: I don't always scare babies, but when I do, it's for psychology. Stay thinking, my friends. So it's interesting. I looked at the picture from the ads for Dos Equis, and the guy who's the most interesting man in the world, he actually doesn't sit like that. His posture in the video in the commercial was kind of turned the opposite way. But an early ad, I think this is an earlier ad, shows him doing this, where he's kind of turned in the same direction and same posture that our friend Mr. Watson has. This is a Psych t-shirt done by Wells Wacky World of Psychology. Pretty cool. I don't think that would get approved at our school. I don't know what to tell you, but probably not. John B. Watson in his experiment with little Albert, an 11-month-old baby. First of all, have you thought about this yet? Is this an ethical or morally correct experiment? Should you experiment on 11-month-old babies? Could they volunteer for this? Could they even know what this was going to be about? I would say no. There's no way they could understand it. So to me, this is pretty messed up, and I don't think it's a very good experiment for that reason. So the white rat is then paired with the loud noise. The white rat, after these pairings, shows fear. Now I have UCS and UCS. That doesn't look right. I don't think I've ever noticed that. The UCS is the loud noise, and it provokes fear. So the white rat, that should be NS right here, the NS. I don't know if I've ever seen anybody correct me on that either. All the years I've been teaching this, they've been using the same thing. I just never looked at it right before. So the white rat's the NS, neutral stimulus, and we need to kind of correct that and make sure it's right in your notes. And forgive me that I did that wrong. In fact, let's pull it up right now and I'll fix it right now so in your notes it'll look correct. We need to go to my notes, which are right behind here. We'll pull them up and do this real fast. Show you the magic behind the process. And this is one of the reasons I like using Google Docs, because I can really easily go through and fix things when they're not working exactly correct and I need to fix it. It's only going to be in one slide that I need to do this. So we just go in here and change UCS to NS, which is the neutral stimulus. And watch this. I'm going to close this window. We'll reopen this. And I got to mix in a little JJ Watt, and he tends to make things better. Let's see what happens. Beautiful. Now we're talking here. So is the CS, let me lower this down. Let's see what we're doing now. I'm making all kinds of noise now. Is the white rat the NS? Absolutely. Is the loud noise the UCS? It's unconditioned stimulus. But if you pair those two together, after several pairings, is Albert going to show fear of the white rat? He does. He later generalizes all kinds of things too. Watson wore a beard, like a Santa beard, almost like a fake beard, for a while, and it was able to generate a generalization of the fear of men with beards. I think this is really crossing the line, and wait till you hear the rest of this. Is really going to cross the line. But the CS is the white rat, the US is the loud gong, okay, and that provokes a fear. The fear is the CR. So another way of looking at it is this one at the bottom where it says before conditioning, then during conditioning you're pairing the two together, and then after conditioning. Okay, after conditioning is the study ethical. According to the standards set up in the late 1970s, it's not, but of course this was in the 1920s, so there's no way this would have been happening. And they just didn't have the kind of standards that we have today. But we have a protection of human subjects and biomedical and behavioral research, and his experiment would not have been allowed for numerous reasons, including the unethical content of which you're dealing with a child, a baby, 11-month-old, but it's now measured morally. It's now measured moral to evoke reactions of fear in humans under laboratory circumstances. And the only way you are allowed to do that is if the participant has given you his informed approval, his or her informed approval that, okay, you're allowed to like horrify me in this experiment. So, is this ethical? Remember the Santa Claus beard? I mean, they never take him through extinction of these learned behaviors. So Albert could have grown up with a fear of Santa Claus, a fear of men, a fear of rats, all kind of fears, because he may have learned these in a strong way as an infant. It's possible. Experiments should not cause human participants any unnecessary distress or to be in any way physically harmful. And if you think back about the experiment that the kids did in my class with scaring the dog, maybe that's a similar thing. And I've had kids in my class say, absolutely should not have done that. And I've had kids in my class say, there's no problem with that. So I guess it depends on your perspective. And that's why there's a little gray area here. But the welfare of human participants must always be protected. I would think the welfare of children is even specially higher priority as well, to protect them. Well, here's the real interesting part of the story, and the sad part is that our man, baby Albert, wasn't actually named Albert. His name was Douglas. He was the son of two people, but I don't believe that his mother was ever married. He died in 1925 of hydrocephalus, which is believed to have developed in 1922. And it could have developed when he was actually born with that kind of a condition. It's really hard to know that at this point. But a number of procedures were performed on the little baby there to show and determine what was wrong. And the records show that hydrocephalus, and hydrocephalus is like water or cerebral fluid in the brain, like more than it should have. The CSF, the cerebrospinal fluid. And what happens is that it progressively enlarges the head. There are convulsions, tunnel vision, and mental disability. Little Albert was very ill, even at the time, when he was going through these experiments, and he could not see well. According to his relatives, never learned to walk. They had to do a lot of research to get to the bottom of baby Albert. This is not known when I was in college, that's for sure. I think it was 2004 that they got to the bottom of this. I'm not positive. There may be a date on that here in a second. But there's evidence that Watson knew of this illness, and bringing into question now the validity of his results too, because if the baby was not capable of being able to see well, certainly, that alone would have questioned some of the results. But the critical reading of Watson and Rayner's report reveals very little evidence, that either that Albert developed a rat phobia or even that animals consistently evoked his fear. That's some person's critical view of it. So, I mean, even the research itself comes into question, and that's why it's weird, though, that we study this in such detail, and you would think it'd be thrown out of textbooks in a way. The reason is because it's very early on, and it sets the groundwork, and it prompts massive subsequent research on the topic. So, in a way, it's sort of like the Stanford prison experiment, something that kind of went wrong, although we didn't know it went wrong for quite a while. It still has sort of a cloud over its head, the baby Albert thing. I'm not going to show these in this video, but this is 5 minutes long. It's fascinating the amount of work the researchers went through to get to the bottom of who little Albert was and to be able to find him. And here's another one from a podcast I sometimes listen to. He put together a video on this. I think this is Michael Britt. It's very well done, talking about how little Albert was found. And then I'm leaving you tonight with a comparison of classical and operant conditioning. But what I want to challenge you to do is go back after we look at operant conditioning and compare the two when you're reviewing the notes again. The operant conditioning is on the right and classical conditioning is on the left. And really be looking through this to try to figure out the difference between the two. And there is a pretty substantial difference. There are characteristics of learning and conditioning in both, but classical conditioning is between two stimulus and stimuli, and operant is between a response and its consequences, which the participant is very much aware of, and in a lot of ways is voluntary. And classical conditioning is reflexive, or almost like a reflex. Focusing of attention on classical conditioning is what precedes the response. Operant conditioning is all about the response is going to evoke. The conditioning itself is going to evoke a response afterwards in the form of consequences. So that's very different. Bodily responses are involved with both. But you're going to get verbal responses involved with operant conditioning as well. Range of responses in classical conditioning is very simple, straightforward. Although CS, NS, UCS, this can get confusing. It's not really that bad when you start to boil it down. You see it a few times. But operant conditioning can get very, very complex. It can be simple, but it can get very complex as well. And the learned response in classical conditioning, it's things like fears and likes and dislikes. In operant conditioning, you're talking about the goal-oriented responses, and that's a whole lot different. It's what could lead people to lead better lives even on their own after you're done. Reinforced schedule comparisons, and we'll see this with operant conditioning. You're going to see the fixed ratio schedule, and I really like this comparison chart because it's looking at response rate and then patterns of response, and then resistance to extinction. And it's real interesting. I mean, I don't think it'll be on our test that, one's better than the other, but there are certain ways that you can reinforce people's behavior, and much more about this when we get to that section. It's reinforcements and punishments, and I just want to mention this now because this is tricky, that a reinforcement increases or strengthens a behavior. And a punishment always decreases or suppresses a behavior. But a positive reinforcer would be one that added something that's positive, like you got money or bonus for doing something. A negative reinforcement would be removing or terminating something pain-producing or otherwise aversive stimulus, like an electric shock. For example, they have an electric shock, they do something correctly and behave well, then they no longer get the shock. That's one simple example, but painful. Punishment is interesting because you have negative punishment. That's when you're delivering a pain-producing or otherwise aversive stimulus, such as spanking, or electric shock. You're adding a negative. So subtracting a positive is removing some pleasant stimulus or taking away privileges, such as TV watching or the use of automobile. Decreasing or suppressing behavior by adding or subtracting. So do you understand more? You add a negative. This sounds crazy, but it's in a way positive punishment because you're giving them something. You could be giving them a spanking. That's positive punishment. If you take away something positive, like you're removing someone's privileges, that would be, in a way, a positive punishment. Removing some pleasant stimulus. Did I say chores? I meant like someone's favorite TV show. So we'll talk much more about this. This can be tricky. I just want to introduce the fact that it's tricky. I even get tangled up sometimes when I'm not thinking well and I'm really tired and not feeling great like I am tonight. Anyway, here at Tiny Tot Preschool, we're proud of our no spanking policy. Of course, they have another policy which is cutting people's heads off, I guess, with the guillotine. Goodness gracious. So that tonight has been classical conditioning. It's a mouthful. There's a lot there to consider and think about. So we'll see you next time when we talk about operant conditioning. And as I always like to say about this point, don't forget to be awesome.